Hello guys. So today I'm going to cover NAT. NAT stands for Network Address Translation, right? So if you were in the CCNA and obviously you have come to this firewall course, so you have covered the CCNA, right? I feel that you are having the basic understanding of CCNA. So you have learned through the that what are these NAT and static NAT, dynamic NAT, and NAT overload, that is also known as PAT. You know those things, but as we are learning through in the firewalls, so I will just brief you once again what are they use. So the first basic question, why we use NAT, right? So if you have any idea, then it's okay. If not, then I tell you that what are the basic answers I see from most of the students, right? So the first answer I get whenever I ask this question, the people answer the question like NAT is the conversion of the from private to public, right? They say it as a private IP to public IP, right? Another answer I get it. That answer is to hide IP address, right? Let's suppose you are an enterprise network and you want to hide your IP address to from the public networks. So in that case, we use NAT. Another some of the people say this is just an translation of IP addresses, translation of IP addresses. And I feel that all of these answers are correct, but that does not give the clear answer that why we use NAT. So the correct answer of this is we are running out of IPv4 addresses. So it means that we don't have any choice. We have to have use the NAT in order to survive, right? Why we use it? Because if you just memorize the things or recall, IPv4 is having 32-bit IP address, right? And if we convert this 32-bit IP addresses, just simple mathematics, how many IP addresses we get? We get 2 to the power of 32. And if you convert that number, you get approx 4 billion IP address, right? And if you just know the population of the world, and if you don't know, you can just search in the Google. That's quite easy to search, and you will come to know that the population of the Earth is around 8 billion, right? So you're sure that all of these 8 billion people will not get an IP address. And if they do not get an IP address, then they cannot access the internet, right? They cannot use the internet. And now some of the people you might be thinking that, sir, so many guys are there that my parents are not using phone, they are not using internet. That's true that some of them, population, all of the guys are not using the internet. But still, there are some guys who are using 4 or 5 IP addresses, right? If you are having mobile phone, you are using an IP, you are using a smart TV, you are using an IP address, and never forget, right? The first thing is laptop or computer you must be having. So that is also taking one IP address. And if you are little uh, tech savvy and you are using any IoT, Internet of Things devices like security cameras or any internet running things like for the temperature or uh, internet controlled AC, then also you are using uh, then IP addresses, right? So there are was some of the people they are using so many IP addresses, but average, I think mobile phones, smart TV, and laptop are common. At least 3 IP addresses are normally used by a uh, average person. So the main thing is that we are running out of IP addresses, and the problem is that you know uh, we cannot survive. All the people cannot get the internet. So in order to sort out that problem, we just invented the thing that is NAT, and it saved ourselves. Now you try to understand that how does it save, right? So for that one, we have the concept of private IP address and the public IP address. We are having some range assigned by IANA, right? IANA is assigning the public IP addresses to everyone, and obviously we are you have to pay to get that IP. Why we pay that? Because you have to register it, and we are running out of the IP addresses. That's also one of the costs that you have to pay for to get the IP address. Once you have the public IP address, you have paid for that one, then only you can use the internet, right? And another part is that this private IP address. So in private IP addresses, you can reuse those IP addresses like 10.0.0.0 network, right? So that's how it is happening with the private and public IP addresses. So these private IP addresses, these can be used by anyone. Let's suppose you are using that IP address 192.168 that 1.10. Suppose this is the IP address of your computer right now because you are connected via broadband or your home Wi-Fi router, and the same IP addresses will be used by some else, right? Let's me give you an example. Let's suppose most of the guys are using IP addresses from one uh, broadband company. Let me take the example of Jio, Reliance Jio, that's popular in India right now, right? So they are using the network 192.168.29.0. So whoever is buying the router or the taking the connections from them, they are just getting everybody getting the IP address from this network. Now, if they want to reach to the internet, so this IP address must be translated to a public IP address, right? And then through this public IP address, they will communicate to the global world or internet. So that's how it is happening. And I'm pretty sure that you have learned these concepts in the CCNA very well. But just to remind you, in case of firewall, because we have to configure it, so you should be recollecting that information that what actually you have learned. Because if you do not remember and if you learned the firewall, right? So that's really difficult because you don't understand the concept, then you cannot implement. And even if you implement, then you just implement whatever I tell you, correct? So let me clear it and explain more. So we are learning NAT, that's fine. And what are the types of NAT? So first, the very clear criteria, that is you are aware that is a static NAT, right? So in case of a static NAT, we are doing mapping one to one, right? So we are having one IP addresses, and from let's suppose you are having that one IP address 192.168 and 25.10 or 25.1, and that is being translated to a public IP address, let's suppose 100.10.10.10, right? So this is just statically mapped. So whenever it is going to the internet, it will use that IP address. But if anyone else trying to uh, reach or get the internet 192.168, let's suppose a user 25.2 tries to reach the internet, so he need another public IP address, let's suppose 100.10.10.10.11, right? So that is a called type of static that we have to use the one-to-one mapping. So this is not feasible, right? Because we introduced NAT to save the IP address set, and still in order to go to the public, we are using one IP address to each other. So that's not practical. That's how we are not saving the IP addresses. So we are not using static NAT uh, in order to reach the internet. Obviously, it is important, In some cases, we have to do it, but normally it is not preferred by our NAT devices, right? If you want to go to the internet, you do not prefer that one. Another type of NAT is dynamic NAT. So what is happening in the dynamic NAT? So let's suppose let's say we are having three users, 192.168.25.1, 25.2, and 25.3. And they want to use the internet, these three guys. So if they want to use the internet, then how they will get it? They need a public IP address. So there was one option, as we discussed in the static NAT, that they will be having unique IP addresses to reach the internet, right? They can reach directly, take this IP address and go to the internet. Another way, for this 25.2, take another public IP address and go to the internet. But in case of dynamic NAT, what is happening? Let's suppose we are having three guys in the private, but we are having just two IP addresses in the public, 10.10 and 100.10.10.11. So now if these three guys want to go to the internet, they can take any of the IP address from this pool, and they will go to the internet. Let's suppose the user one, let me change the color. I think it will feel you good. So let's suppose this user want to go to the internet. So he just take this public IP address and goes to the internet. Now, if this another guy, 25.2, if he is trying to reach the internet, so the first IP has been taken by the another user, so this is not available in the pool. And now, if he is trying to reach the internet, 25.2, then he will take another available IP address in the pool, and he will go to the internet. Now, what if that 25.3 is going to access the internet? How he will do? He will try to reach that pool and find that, oh, I don't have any public IP address. So he will not be able to access the internet. So you might be thinking then, no, why we, what's the benefit of that one, right? The benefit is that because sometimes what happens if you do the static mapping, then 1.1 is 25.1 is fixed with 10.10, 25.2 is fixed with 10.11. Now, if by chance, let's suppose this is a night time or this guy is not accessing the internet, but this is reserved for that, anyone else cannot use that IP address. But if you are using the dynamic and this is available on the pool, if this IP address is free, right? If this is free and this 25.3 reaches this pool and finds, oh, looks like that 10.10 is free. Seems that this 25.1 is not using that one. Might be any cause, he shut down, he's not using, or whatever the reason. The thing is that 25.3 can use the 10.10 IP address and go to the internet. So this is just a benefit of using the dynamic NAT, that pool is IP addresses are falling. Anyone wants to access the internet, come to my pool, use that available IP address and go to the internet. It's like you are on the river, right? Let's suppose this is a river here, and there are some boats. Let's suppose three boats. There is so many crowds here, right? There are so many crowd here. Everybody wants to cross the river. So what happens that let's suppose this guy wants to go to the cross the river, so he just comes, takes that boat, goes cross the river. Another guy comes, he finds a boat, cross the river and go. Third guy, let's suppose this guy comes first, he comes to the river bank, take a boat and go. Now if the next guy comes that he does not find any boat, so he cannot go, right? But if anyhow let's suppose this guy, he is not going to the internet, or if anyhow let's suppose someone else has returned or something, or he has not gone to take in that boat is available, so this guy can take that boat and go to the other side and can cross the river. So that's what is happening with the dynamic NAT. Another thing that what we just discussed, the third one, that is then we also call it as NAT overload. right? People also call it as PAT. And the most used technology, PAT, name stands for Port Address Translation. So I think I have to discuss a little more about that one. So let me clear it and then explain only PAT. So you might be aware that in TCP/IP, whenever we are initiating any connections, so there is a source port and destination port, right? So what is happening in case of the PAT, that let's suppose this there is a I'm taking 10 users right now, 128, 10.1, 10.2, 10.3, and 10.10. These are 10 users. They want to reach the internet. And in case of the static NAT, we need 10 public IP addresses to reach the internet. In case of the dynamic NAT, we may have to use the 10 IP addresses for if they all the users concurrently want to use the internet. And if all the guys do not want to access the internet at the same time, we may have to use the less number of IP addresses. But what if that all the guys want to access the internet and if you have only one public IP address? So that problem is sorted out by PAT. What are we doing? We are adding one extra field, that is the port number after that one. So there are some reserved ports, right? Or we can say well-known ports. So we are not using those ports, but we are using the free ports available, right? So well-known ports we are not using. We are just using any random ports to reach to the internet. It is being translated that let's suppose this 10.1 is trying to access the internet. So it will come to this, right? It will take that IP address, add a port number. Let's suppose I'm using 3000, right? If I use this 3000 port number, right, and just go to the internet. Another person comes to this pool. They we add another like 100, that 10.10.10, and after that one I added the port number 3001. And else came I will use another port 3002. So with this combination they are going to reach the internet. And how this is being managed, if anyone else reply with that, because they will be replying with the same port number, right, 3000, then how it will be going to that the same IP address who has requested, how they will know it? So for that purpose they are using the NAT table. NAT table, or we also call it as a translation table. So they are having a mapping in their table that I have added. Let's suppose this for 192, 168. Let me write only the last one. For the 10.1, I have used 10.10, 3000. For 10.2, these are the private one and these are the public one, because both are you know pub 10.10s, you might get confused. So this is this side, and let me change the color, and this is that one, right? So this is 10.10 port number 3000 and 10.10 slash 3001. So once we get the reply, so when we get the reply, we just check this table that okay, if the reply is coming to that port number 3002, it means that it just checks the translation number and comes to know, oh, this has been requested from 192, 168, 10.2. So he will deliver to specific to that. Sorry, this should be 3. So this should be delivered to 3. Or if it is in the translation table, it is coming to this. It will check the requester, that who has requested that packet, and it will be delivered to the concerned IP address. So that's what it is happening in the NAT, right? So I'm sure that is you are pretty clear with that one. If you have any question, you can reach me. And if I talk about the translation type, right? It is being translated based the source IP address is being translated, or the destination address is being translated. So that's one more type is also called, that is called as SNAT or DNAT. So let me just explain you that as well. Let me clear this, right? So what is happening? Let's suppose we just quite clear that we are having that static NAT, dynamic NAT, and NAT overload, that is a PAT, we call it as. Okay, so obviously that is possible, and whenever we are using in normal scenarios, we are trying to reach the internet. Let me take an example of a firewall here. Let's suppose this is your firewall, and there are multiple users there, right? And then they are trying to connect to the firewall. How they will use? Here you are having the just a private IP address, and here it is a global world. They are using the public IP address. So here you are using the network 10.1.1.0 network, right? And here you are using the public IP address 10.1.1. Let's suppose 1. This interface is having the IP address 10.1.1.1. Now, if anyone trying to reach the internet from here, how will they go? They will just come to here, right? 3, 2, yeah. So now if they try to reach the internet, how they will do? They will come here. They take a port 10 dot from this 100.1.1.1 on 1.1, and then after that one there is a port number. That port number can be anything, that is a random one. We do not just specify that one. So let's suppose for simplicity, let's suppose that is 2001, right? And then it goes to the internet. So what is happening here, that our source IP address, right? If you go to the IP header packet, there is a source IP, there's a destination IP. So if source IP means that who is requesting. So let's suppose this user is 1.1. It means the IP address is 10.1.1.1, and destination IP, let's suppose it is accessing any of the server of 200.20.20.20. That is the destination, any of the web browsing server from any of the company or website, and they are trying to access that one. So what is happening here, that destination IP is not being changed, right? That destination IP, if even if it is being converted like that one, but the destination IP address will be still be the same, and that will remain as it is 200.20.20.20. So what is changing here, the source IP address is changing, right? Source IP address is being translated. So when the source IP address or the source is being translated to the another IP, then we call it as SNAT, because the source IP address is being translated. But what if that our destination IP address is being changed? You might be thinking that how the destination IP address can be changed. Let me change the scenario, and let's suppose you are having one DMZ server here. DMZ might be any HTTP server, any Apache server is there, right? That is standing here, and anyone trying to access a web page from that server. Okay, let's suppose this is your website, uh, any xyz.com, and that server is here. Anyone can access that one, correct? So how the user will come? So user will come here, they come here, and now if you want to save that IP address, sometimes you are having only one server, sometimes you are having the multiple servers, right? In the big enterprise level, they are having redundant server. They do not have just one single server. If that server goes down and they are not able to access the internet, or any services that service gets outage. So normally they are having the multiple uh, servers, or even if they are having that HTTP service here, and let's suppose they are running that FTP server, right? So there are two servers, let's suppose, running, or SMTP server. Any server can be type of that's depending on the type of server you're using, that a mail service or file transfer or just a web browsing service, whatever you are trying to reach. So the main thing is that now if any user XYZ IP address and they have requested to your server and your IP address, what they will request for? They will request for this 100.1.1. 100.1.1.1. Now, on which server they want to go? They want to go on HTTP, they want to go on FTP, or even if there's a mail server, SMTP. So there they want to go, where they want to go. So based on that one, how you do? You use that port number, right? So let's suppose they are using HTTPS. So they will be using a port 43 or 80. Let's suppose HTTP. So they will be using a port number 80. So now once that packet hit here on this your firewall interface and it is having the port number 80, then what you have to do, you have to translate that combination, that's we can call it a socket, right? So you, or if you do not understand socket, then it's also fine. So what you have, this combination of this 10.1.1 to 80, that you have to translate to the server which is going to the HTTP, because it might be case that you're running the private IP addresses 1.1 is for SMTP, 1.2 for the FTP, 1.3 for the HTTP. So now you will be translating this service that whenever someone is trying to reach that port 80, I have to send that packet to the HTTP server. If you send that one to the FTP, then he will not get the response because he is requesting your web page and you are sending something FTP file to them. So that will not appropriately work in their system. You need is current service running on your server. If you do not redirect the request to the appropriate server, the user will not get the response. So what is happening here? If I do like that one, so 100, that was the destination address here for this user who is in the internet. That was the destination address here, and the source IP, that's what destination IP, and the source IP, what from where the user might be requesting any public IP, let's suppose 20.1.1, right? Or any private IP that can be, I don't care that what source IP here, but somewhere some source IP, and the destination IP should be there because they are trying to reach the our service. So now this translation, right? Just focus that this translation from 100.100.1 to this our service translation, that is called actually DNAT. DNAT means destination IP address translation, or destination IP address is being translated. So that's why we call it as a DNAT here. You see, right? This is the destination IP address. That's what we are working for. And whenever the request from this side, that is a source IP address is being translated. So that is SNAT. And whenever it is coming reverse like that, then we are not here, sorry, to the DMZ server, right? The public facing server. So there we are using the DNAT. So that is the concept like SNAT or DNAT. So it depending that which IP address is being translated, either it is a source NAT or the destination NAT. We just categorize it to that's SNAT and DNAT. So the same thing, if you just observe, let me clear a bit because this is going so much messy. So let me clear it and explain once again, right? So this was your firewall, and here was your some private IP addresses. It was some DMZ server, and here someone from the internet was trying to access your FTP server. So now if you that guy is using that 100.1.1, let's suppose IP address, and here you are using any private IP address you can use, right? So if that is being translated, that translation uh, will be static, or it will be dynamic, or it is being on the patch port address translation. What do you guys think that what it can be, or what it will be? In fact, not it can be, what it will be. Anyone is having clue? Now, let me tell you that that is an static NAT. Normally, we prefer it at in static. Why we do it, right? Because this 10.1.1 based on that service, let's say it was in service 2. So that IP address is being translated to specific DMZ IP address 10.1.1.1. So this is a static mapping that whenever any request comes from port 80, please redirect it to 10.1.1. If you have any that FTP server request or SMTP server, right? So if any, let's suppose this is an SMTP and the port number is request is coming like that 10.1.1.1 colon 25. That's port number is 25. So port number 25 is for the SMTP. So we have to redirect or we have to map to this IP address 1.1.2 always whenever the request is coming for that port number 25. Please send it to this server. Do not send it to the this 1.1 the that normal HTTP server. So that's what is happening and we use it and a static mapping for that one. Although some of the guys are getting confused and they call it as because the source IP addresses will be different, so that should be a dynamic one, right? Because there are multiple users there. So obviously their source IP address is different, but their destination is always same. They are always hitting this 100.1 dot. Oh, I think I have missed 10 dot. It should be 100 dot something, right? So 100 because that's public. Although 10 does not matter, but why I'm showing it here because 100 is a public IP address, and whenever using publicly, that it's good to give example like that only, not like a private one. So that 100.1.1.25, so they are always hitting this IP address 100.1.1, all the users. And what we are translating only this IP address, single IP address. So that's why that is a static NAT. Although their source IP address are multiple, so but still that is not a dynamic one. Okay, guys. So let's explore more by taking the lab session and that how actually these are being configured in the firewall. Okay, guys. So this is our as usual lab, right? So here we are having computer, manager, gateway as previous one. There is no change in that. Let's open my window machine here, right? So this is it. And let me just test the connectivity, that if all is well or not. And the gateway IP addresses are this 50 and 51. I have not changed them and they should be reachable. 10.1.1.50, they are not. Let me check the machines if they are on or not. This is my manager and here both of them are logged on. Let me just, okay, let me open the switch as well because sometimes, yeah, that's the same problem. I understand that this switch interfaces does not come up if I does not enter it no and to enter the configuration mode. So next time what I will do, I will just save this configuration, but still I think even it has to boot it up, you see. So now all interfaces are up and it will start communicating now. Yep, here it starts. All is well. Guys, today I was just watching movie Avengers Endgame. I understand that you might be missing that lady Scarlet. See, Natasha name was there. Nat. Ah, her name was also Nat, and we are also learning Nat today. In the movie, they used to refer her as a Nat. Her name was Natasha actually. So, anyways, let's not discuss the movie here. What I was saying, yeah, we were learning Nat. So let's open the smart console. It's a long movie, but it's really good. I really enjoyed it. It's around 3 hours. But I just never felt it so bored that it is so boring. Although it's a long movie, and but sometimes I feel that it is little slow because they are just showing everyone's life. They are going back how Captain America, Steve was there, Bucky is alive. Even that guy, what his name? Iron Man, huh? Right? Who can forget him? Tony Stark. He's also used to go in the past and meet his father and that discuss about that how he was born and how his father is feeling. So that's some funny moments. And necessarily they haven't used it, I think, just for fun. But yeah, it was a movie, so I enjoyed it. You can also watch if you get time. I think it's really good. You can just watch it. Guys, that why I watch these English movies, and I recommend you all because this really helps, your communication skills. If you listen good English, you always try to speak like that, and it really helps to, you know, improve your accents. In fact, I should call it accents. I was having an English class, and then lady was saying that you should call it accent, not accent. Then sometimes I'd say it's an accent, and sometimes I like accent. It's just always fun. So we were seeing the security policies, and there is an option for the NAT here, right? Where is this? This is the NAT. And you see that there is a thing like automatic rules and manual lower rules. So this is in the where I can say that in the checkpoint we are having the two options of the NAT, that we are having that automatic rule and the manual rule. So this automatic, it doesn't mean that there is some automation or we are running some script for that one. There's nothing like that one. These the automatic rules. Whenever we say, it means that they are within the objects, right? Within the objects. And that's the best part of these automatic rules, is that we do not have to give these internal IP addresses and all, and the internal IP address we have to give, but we don't have to define and everything. You see that all these options automatically come. You don't have to attach it any of them. But whenever you are creating any of the manual rules, you just create an entry like this, right? And from the here you will just add a new rule, and then you just get that pre-nat original source. So original source, as usual, there's no changes that one, like original source, original destination, then translated source, translated destination. There will be on the right that translated destination. Let me scroll it, right? So, and let me clear it as well. So that's what it is happening, right? Because we know that it is having we are learning the translation, and in case of translation we are having the IP address which was before natting, and there is an IP address that has been natted out, means that translated. So that is the original IP address, original destination, right? And before that one it was an original source, right? That what was that I think let me scroll a bit left as well, so that will show you that original source. Now it's fine. Original source. Let me correct it. So that is an original source. We are having an original destination, right? If you from your computer, the packet were originated, and your computer was having an IP address of something 10 dot 1 dot 1 dot let's say 50, let's say 10, and it was going to the Google server. Let's say this is for the DNS 8.8.8. So this is the IP address that you will send as an original source is this 10.10.1.10. Original destination will be your 8.8.8. Now original service as usual, that is not nothing going to be changed as of now. We can change that service as well, but normally we do not do it, because this, let's say this is an HTTPS service, so it will put an port number of 80. So we are not going to translate of as of now, but if it's required, then we can move. That is also whenever we are changing the port, that is known as the port forwarding. We'll come to that in the, I think, next session, because that's also I have to take a theory session for that one, so I will do that later on. Let's focus where we were there. So that is our original IP address, that is original source, that is original destination. Then it comes the term of translated source, means that our translated source is like we are using what the IP address here, public IP we are using, let's suppose 10 dot 1 dot, no, not 10 dot something, I think it was some other IP address. It doesn't matter that you have to be public IP. It can be any IP, but it has to be translated, right? In our case, you see that my IP address is being translated to 192 or something, 192.168 or dot 137 dot something. I think it was I'm not sure, 36 or 35 or 6 something. So when it is having a rule that whenever the IP address is get translated in this IP address, then only it will go to the internet. So what we are going to do, we are translating this IP address 10.1.10 to this 192.168.136.7, right? So that's what it's the translation. So in that case, our translated source will be this IP address 192.168.137.36, and the destination will be same 8.8.8.8. We're not going to change. If I change the destination, it will go somewhere else. It will not reach to the Google DNS. So we are not changing. This is as usual. Destination ID is destination IP address is same. We are just changing the source IP address. So that is what we call it as a source NAT, because we are just changing the source IP address, and that has been this is going on ongoing on within the object. So that's why it is called it as the automatic rules. So let's just explore a little the options on the checkpoint and how they are. You understand well with that actually, and let me show you that policy as well. So that's what I was talking about, that my IP address is this 10.10.10. It is being translated to this IP address 192.168.137.134. Normally, if you go to the real environment, wherever you are having an enterprise network, this IP address is normally a public IP. But in my lab setup, that is not a public IP, but I'm using this IP address as a public IP address, because obviously I have to pay a lot of money to get a public IP address. So I'm not so rich to pay that money and teach you free of cost. So I not say the free of cost, it's anything, whatever it is. So right, so that's how it is. The things are like that one, correct? So this IP address 10.1.1.10 is being translated to this IP address. Obviously, it will use some port number, so we will see that one, that in which port it is using, and it will see that translation, and then it will go to the internet and go return it back. We will see that NAT translation as well, right? So that's what it is happening, and let me just show you that how it is in the our, I forgot it, in the computer, that is known as the smart console. Yeah. So if I Go to this internal. There is an, I said that for the automatic rules, we go to the network objects, and we are doing it within the networks. So this rule is that for the internal, and I remember it was inside the networks. No, networks is empty. I forget it. I think hosts it was. No, host is also empty. Then where it was that under the NAT, gateway and servers? I think, yeah, here, this is the gateway and this is the manager. So now if I click it here inside the manager, no, 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 not this one. Gateway, no, not this as well. I think I missed that. I think it should be under networks. Yeah, that's the one. Not this. And that was the management PC, because I think here, if you remember, that should be some management PC here. Why it is not closing? Internal hiding, and here it is internal, internal, or let me do like that. Let me just delete it, right? That will be a good way. Because if you do it, I introduced it just to test the connectivity to the internet. On that time, I said that I will explain later on, and so now the time has come to explain it. So I think it is the internal one. Let me delete it if that deletes that rule. Fail to delete object, and object internal is used by the policy by other objects. Okay. Let me delete this management PC. I think I'm using that under the policy as well, right? Internal. Okay, okay. So here also we are using, right, this internal. So that's why it is not allowed to change it. So if I remove it from here, then only we can delete it. So anyways, just do not delete it. Let's understand the concept that what I'm telling you. Let us suppose that if you want to make any of the rule, and you want to NAT it to some other IP address, right? So if I go to that here, internal, let's, because that I'm making a NAT for the internal IP addresses. So if you go here, if you see it, that I am just for the internal network, I'm using that 10.1.1.0 network and 255.255.0. If I go to the NAT here, you see that I have added a NAT rule here. What is that NAT rule? Normally it should not be that checked. Okay, it is that arrow, how that arrow will move. Yeah, let me go like that. Yeah. So now if I click it here in the if I click it here, this option, add an automatic address translation rule. So I'm adding an address translation rule, means that I'm enabling the NAT here. And in that NAT, we are using the translation type as an height, right? So let's just explore that for how many options we are having. So option, we are having that height and static. So whenever we are say that option of that height, so this height means that we are using the dynamic NAT. These are the terminologies of the checkpoint firewall. Dynamic firewall. Sorry, dynamic NAT. Dynamic firewall, I'm saying. And static is as usual, that is 1-to-1 mapping. Why we call it as an height? Because whenever we are just using that firewall, and we are using an IP address 192.168.137.134, and this left of network, irrespective of how many computers there are, they all behind this one, they are hiding behind this IP address. Whenever this it is going to communicate to the global world, they will know only this IP address, that the request is coming from this IP address. So that's why we call it as a term as a hide, means that whole my entire internal network is hiding behind this IP address. So that's why we use the term as a hide here. But this is a specific terminology for the checkpoint only. If you go to any other firewall, you do not see this option of hide. But yeah, concept is same, the static, dynamic net and all. And now if here what I'm doing, I'm just hide behind the gateway. But if I don't want to use that specific IP address for 192.168.137.34. Let me show the topology here. This IP address, right? If I don't want to use this IP address to go to the outside of internet, then what we can do? We can use this option, hide behind an IP address. Now, as I click it here, it will give you an option to configure an IP address. You configure it 10 dot not 10 dot something public. Let me give some public IP address 100 dot 10 dot. Okay, 110.10.10. So if I click this one, this IP address like that, and click it OK. So now what will happen, that if now my packet, whatever I'm using here from the Chrome, and if it goes to the internet, it will use this IP address 100.100.10.10 to reach the destination. So let me check if it is Google is working. Yeah, it is working fine. So I think there should be some logs of this NAT. So let's check that how the conversions are happening. Yeah, I think still it should be working. I think I have not made any changes. Yeah, even I have don't have to, I haven't published it. So even if I by mistake do any changes or done something wrong, I do not install the policy and publish it. So that's all, everything should be as before. I was saying to check the logs. In fact, the NAT translation. So here it is, and that is for the logs. These for the security policies, that which of the rule is hitting which of them. But we do not see the NAT translation, right? You can see that how the IP addresses are being hit, or see the logs here, right? And if you see the rules and NAT, then you can just hover over here, this, right? So you see that IP addresses, that how the IP addresses is being translated. So you see that right now it is still showing as 10.1.1.0 because it is hiding behind the internal network, right? Let me scroll it. It's, you see that an option internal hiding, right? So this network is hiding behind the that IP address 192.168 or something. Perfect. So that's what it is hiding, because this is hide and hide behind the gateway, and gateway IP address, we know it. So that's what it is happening. And if you want to see some logs of that one, that is just really not easy. So you can just run that command, firewall ctl connection tab. So it just give you a little brief that how the traffic is traveling, that what is the source IP address, what is the destination IP address. But still that difficult, that's not user friendly, especially the checkpoint CLI is not user friendly. So if you quite good at it, you can go ahead with this. If not, just trust on the GUI and keep playing with it. So that was about the automatic rule. And if you want to add a rule, let me just add one more rule, because that's what it will give you the clear glimpse that what is going to happen. So let me add a rule for a host, for the specific host. So let me take another IP address, let's say my PC, right? And for that my PC, the IP address of that PC is let us suppose 10.1.1. Let me say 60. Okay, so that is the IP address of that machine, and now I want to use the NAT for this one, so I will go for the option of NAT here. So as I go it NAT here, I click, just focus on the this are only two rules, right? This one and two. If I click it here, add automatic rule translation, and here the option I get that hide behind the gateway or hide behind an IP address, because this is no totally virtual, because I don't have any IP address of that 60 IP address. This IP address I don't have in my network, so that is total hypothetical I'm telling you. So let me just tell you that hypothetical this thing as well. So that IP address, let me say that if I give it 100.10.10.10, right? And now if click it OK, this, you see that these two rules are there, automatically the rule will be created for that one. If I click it here OK, so that now the automatic rules has been generated. Now you see that you don't have any rules for that. So you were saying that there will be rule for that and there's nothing generated of what is this? So the rule is being generated, my friend, and this is inside this. You see that my PC, that's what we added, and that has an automatic rule for that one. And you see that what is IP address here? This is hiding behind the 10.1. This is the computer IP address, and the translated is the original one. I don't see that 100 dot. Oh yeah, that will not show because that is hiding behind that one. So that's why it is, because it has hidden. So that's showing the previous one, 10.1.1.60. So that's how the thing are being done, and you can add that automatic rule. While if you go for the manual rules, how you will add? You will just add a rule top or below. So let me just add rule below of that. Okay, so now you have to give your name of that rule. That I'm not going to add it right now. I will just show you in the next class with the sum theory and the port forwarding. You can just create an object and you can attach it here using it here, right? So that's what it is, our manual rule. So we are not going to do that manual rule right now. So I think that automatic rule is sufficient, because I don't want to make that video too long, because it's already around 1 hour speaking. So I just don't want to make it too long for you guys to stretch it, although I'm sure that you guys are not watching it at one go. You just watch for 5 minutes and go to sleep, and then sometimes you wake up and then remember, oh, I have missed it, so you watch 20 minutes more. So I just say you that keep on learning. If you do not learn it, you do not practice it, and you do not make a regular habit of learning, then it's really difficult for you to learn any of the skill. Anyways, that's my job to tell you learn, learn, and learn. And you're pretty sure that you say, oh, let's sleep today. I will do it later on. I will do it tomorrow. Okay, guys. So yeah, first thing first, and let me also show you my website. Right. So this is my website here. Where it is? Oh, yeah, it was here. freshdeveloper.online. Right. So I think you can go to here, checkpoint firewalls. I'm sure that it might not be a case that after 2 years I will try to keep this space, not to remove it, but still if GUI is something else, then you will get an checkpoint firewall. I will not remove these videos from the YouTube. You can always find them. So that day 6 I'm recording, and it will be added it here. And if you are quite pretty sure, and if, yeah, very important part, if you have not set up the EVNG lab in your machine and your computer is quite good, at least 8 GB RAM is required minimum. If you have that, you can go through this video, and you can set up your own lab by VMware Workstation and EVNG. I will have also shown that which of the files you have to download and set up in your machine. And yeah, day 6 I will be adding it here, day one by one. Okay guys, that's sufficient, and see you soon in the next video. There I will discuss more about the NAT. One more session, yeah, at least required. Till that, bye bye, see you soon. Thank you so much.